Hello everybody, welcome to NEET Physics by Arun video channel. In today's video, we are going to deal an MCQ in the chapter the electromagnetic induction and alternating current, EM induction and AC current. Okay, what is the question, sir? Let us look into the multiple choice question. It is an inductor of inductance 2 millihenry. It means what? 2 into 10 power minus 3 Henry. Milli means 10 power minus 3. Is connected to a 220 volt and 50 hertz AC source. Definitely it will have reactance, is it not? The inductive reactance in the circuit is X1. Okay? If a 220 volt, the same voltage, DC source replaces the AC source, then in the circuit the new inductive reactance is X2. The values of X1 and X2 respectively are published. You are given 4 options: 6.28 ohm, 0. It means what? In the case of AC, reactance is 6.28 ohm. In the case of DC, the reactance is 0. Option 2, 6.28 ohm and infinity for DC. Then for the third option is 0.628, 0, and the last one is 0.628, infinity. Okay, you know that in the case of AC, that is alternating current, the reactance of given by an induction coil is X1 is equal to omega L. Okay, so what is omega? 2 pi m into E. What is L? Inductance of the coil. So it is equal to 2 into the value of pi is 3.14. Of course, you know, into frequency 50 hertz into 50 into 2 millihenry. That is 2 into 10 power minus 3. So 2 into 50, 100. 100 into 2, 200. 200 into 3.14. 628 into 10 power minus 3, that is equal to 0.628 ohm. So the answer is in between 3 and 4 only, not here. Okay, that's okay. Then for DC, the reactance is X2. What is the formula? Once again, omega L. What is omega of a DC? What is the frequency of DC? Frequency of DC is 0. Is it not? So 2 pi f, 2 pi into 0. So omega is also 0. Then the product of omega and L will also be 0. So X2 is equal to 0. It means what? The values of X1 and X2 respectively are, the values of X1 and X2 respectively are 0.628 ohm, 0. This is the value. So option 3 is the right answer. We will see some other problem in the same chapter, electromagnetic induction and AC current, in the next video. Till then, thank you one and all.